Okay, and welcome to Mr. Friedman's Math Talk. Today we are going to be graphing some functions using our first derivative and second derivatives. So anyway, here's your first function, and what I would suggest that you do is you pause the video right now and see what you can do. Okay, so hopefully you have had time to go through and do your stuff. Now, if you needed help, I'm going to kind of guide you through it. So the first thing you need to do is you need to take your f of x function, and we are going to go and look at all the different things that we can see just from the pre-calculus stuff, just from the f of x function. So the first thing is, let's look at what the domain is. So I think you guys would agree this is a polynomial. So our domain goes from negative infinity to infinity. Next, normally we're going to go look at things like horizontal asymptotes and vertical asymptotes and all that good stuff. So we should go look at vertical asymptotes, but we already said the domain was negative infinity to infinity, so that kind of implies there are no vertical asymptotes, but of course feel free to double check. And in terms of horizontal asymptotes, again, this is a polynomial, so there are none. So the last thing we need to do is we need to go find x-intercepts. So reminder, in order to find the x-intercepts, you set the function equal to 0. When you solve this, what you are going to get is you're going to get x equals plus or minus the square root of 1200. And again, all I did was just solve that equation above. By the way, that is about 36.6. Okay, so position function is done. Time to move on to your first derivative. So let's do that. So right now, I want you to go through, take your derivative, go find your critical values, 5 intervals of increasing and decreasing. So pause the video now. Okay, so I'm back. Let's see what we got. So taking our derivative, when I took the derivative, I got x squared minus 400. So again, in order to find the critical values, you set that equal to 0. So we get x squared minus 400, which gives us x equals plus or minus 20. So these are our critical values. So let's go make a sign chart for this, and I guess I'll make it right here. So our sign chart's right here. We got negative 20 and 20. So let's see, it's gonna go, looks like it's gonna go positive, negative, positive. And again, feel free to double check me, but that is correct. So we got a maximum when x equals negative 20, and we got a minimum when x equals positive 20. And at this point, we need to actually find out what those points are. So think about how do you find those points and go find them. Okay, hopefully you have found those points, and your points would be negative 20 and 5,333 and 1/3. If you're not sure how I found that, again, I took negative 20 and I plugged it into the position function. Again, anytime you want to find a point on the graph, you plug it into your position function. The other point is 20 and negative 5,333 and 1/3. Okay, we have taken the first derivative. We have found all the good stuff that we can find from that. Now it's time to take the second derivative. So our second derivative is f prime of x equals 2x, which means we're going to go find any points of inflection. So we set it equal to 0, and we get x equals 0. So for our second derivative, you should make your sign chart. So the sign chart we have here, and it is positive here and negative here. So it is concave down from negative infinity to 0, and it is concave up from 0 to infinity. Okay, it is time to make, before we make that graph, we of course do need to figure out the point 0 what, right? We do need to know our points, so it's 0 what. Think about how you're going to find that. Hopefully you realized it was 0, 0, because again, we take 0 and we plug it into our position function. Okay, now the fun part, time to graph. See what you can do with this. So pause the video now and graph it. Okay, I am back and I am hoping that you have a successful graph. Let's see what we got here. Let's graph this in purple. That sounds like a good one. Okay, so we got some points here that we need to look at. So we've got x-intercepts at negative plus or minus, right? Square root of 1200, which is, I'll put a plus and minus there. So plus or minus 36.6. So I am going to estimate that. I am going to say that is right here. So this is, we'll say the negative root 1200, and this is the positive root 1200. Again, these are our x-intercepts. Next, we're going to plot our critical values from our first derivative. So we had the point negative 20, 5,300, whatever that number is, that big number. So I'm going to say that is here. Again, obviously this is an estimate. How about not drawn to scale, right? So that's our, what we said, that was a maximum point. So we have a maximum point there, and then we have a minimum point estimate right about there, which is this. And again, this is our minimum value. So, okay, we got those. We got, next thing we should put in that point of inflection, which happens at 0, 0. That's an easy point. Okay, now let's look at concavity and all that good stuff. Let's put it together. We got our points now to put it together. So, going to our sign chart for our first derivative, what do we know? We know, actually, let's just look at this piece right here. So we know that going to negative 20, this thing is increasing. Okay, so it is increasing all the way to negative 20, when x equals negative 20. But at the same time, we know it's also concave down all the way to 0. So it should look something like this. And again, it's a maximum there, so I think I'm justified in making it kind of start to go down there. And let's see what's going to go. From negative 20 all the way to 20, it's decreasing, and it's concave down to 0. So it's going to look something like, you know what, let's do a better job with that. So let's make it look like that. So it's really concave down this time. Now, again, at 0, the concavity changes, but it still decreases. So our concavity changes, but it still decreases. And we have a minimum there at 20. Now, at 20, it's going to be increasing. So according to our sign chart, we're going to be increasing, and it's again going to remain concave up for the rest of our function. So it's going to look, whoa, finger pains, not like that. It's going to look like this-ish. So let's see if that makes sense based on our sign charts. So again, going to our sign charts, and I'm just going to kind of do this in, how about a lovely green? So looking at our f prime, we increase all the way to negative 20. Increase all the way to negative 20. We are also concave down. I think you guys would agree, we are concave down. Now, from negative 20 to 20, we are decreasing. So this is decreasing. And from negative 20 to 0, it is concave down, which it is. And then from 0 to 20, it is concave up, which it is. Finally, from 20 to infinity, it is increasing. And it is concave up. Perfect. It's beautiful. We did a great job. Give yourself a hand.